So like I said, we're taking the boys in that group, and then we're saying of the boys, we're only going to pick these two to represent all the boys in that group. So then if we're talking clusters, we are looking at dividing, again, our population into group. So this time we're dividing populations into groups, but then we're only choosing some of the groups. So we're not taking all the groups, just some of them. Okay, so then convenience. These are the ones that you want to be very, very careful when you're watching for these ones, because researchers question the subjects that are most convenient to them. Usually the people who are most convenient are only people who will speak positively. So these are only going to be the people who will speak positively about the particular company or group. If we're looking for voluntary, the subjects volunteer. These are usually like the people who post on like Yelp and they give the reviews. They're volunteering their information to be part of the study. These are usually going to be people who already feel strongly about whatever it is. So these can be very biased. Okay, so then snowball. This method that we're talking about with the snowball is going to be, I interview you and say, hey, who else should I interview? And you refer me to some of your friends, and each of your friends that I talk to, I also ask them to refer me to somebody. So this is kind of a refer a friend method. Okay, so we're going to refer a friend for this method and see how this is a lot of information. So I would recommend that you have this handy when you're going to do your assignments or when you're going to do your project for this week. If you haven't already started, this is a good thing to have handy. All right, so misleading statistics. So these are the things that are put in place to skew you or make you think differently, to change the perception of the data that's being presented. So these are the buyer bewares. This is where you're looking out to make sure that the data that the company is presenting to you is in the most favorable form for you to make the best informed decision. So if we're talking about numerical data, well, how the data is being represented, well, mean. The mean is only a good representation of the data if it also includes, if there are outliers in there and if they've included it in the mean or if they've excluded it. So this set of data right here, if I take my mean here without the outliers, then my mean for this, I take, because 0 is the outlier, so I take my 80 plus my 85 plus my 90, then I divide it by 3, and I'm going to end up with 85 for my mean. While if I include that outlier of 0 and I add all 4 of those together, so my mean with the outlier, okay, so add all 4 of those together, divide by 4, I'm left with a 63.75. Notice the difference between the two numbers that I have. Notice the big difference. So that definitely makes me want to know whether or not they included the outliers when they gave me my mean for that data. So then if I am talking about my median, so I'm here, okay, well, if I'm looking at my median, well, that can be polarizing too, because I'm knocking a value off of each end. If I'm talking about ages of people at a party and I want to know if I want to attend this party, and they only give me the median age, so okay, that's 1 off of here, 1 off of here, 1 off of here, 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 and here. Oh, look, that tells me the median age for that party was 15. Well, that's not a proper representation of that data, because how many 15-year-olds were there actually at that party? Well, just 1. So if I'm a teenager, am I going to really want to go to that party? Probably not. So this is not a proper representation of the data. Okay, so that's not going to give me the proper representation of the actual ages of the people at the party. They range from 10 to 70. So if I'm a 15-year-old, I may not want to go to that party. If I'm a 20-year-old, I may not want to go to that party because it looks like a bunch of adults and their grandkids. But you want to make sure you're paying attention to that when you're assessing the data. So now if we're looking at our mode, so this is a value that's overrepresented. So we want to be careful of these ones too, because it can be misleading depending on how they use it. Most people don't get the side effects. Okay, well, most people don't, based on the scores. But that doesn't mean people don't. It just means that a lot of people didn't. That doesn't mean that they're not giving you the percent for a reason. So this can be misleading depending on how it's used. Okay. Now our range is affected by our outlier, so we want to be careful with that because my outlier on this one is 8,000. So if they're having you believe that your salary, you can make the salary range is 7,000 because my range, I'll slide up with the outlier is 7,000. Yay, that sounds great. I'm thinking, well, I'm gonna be closer to that 8,000 range. I'm good with that. However, if I take that outlier out, and so I take my range without the outlier, then I see that it's closer to just 300. My range is just 300. So most people make between 1,000 and 1,300. I don't want that. That is not a good look because you're not going to be on the higher end. You're more so going to be here towards the lower end. So then you kind of have to weigh your options. Is that a good job for you to take? Because most of the people are only making within that range. You want to probably be making more towards here because that's more money. So you want to take that into consideration. And your standard deviation is always going to be affected by the smaller data sets. So you want to keep that in mind. Usually if your data set is smaller, then your standard deviation is going to be smaller. So you just want to keep an eye on that. If we are talking graphical, so if you're looking at your graphs, that's all graphical means, looking at a graph. So if we're looking at a graph, you want to watch out for broken graphs. That means they are possibly going to be skipping numbers. Size of objects, so they're going to use oversized images to make something look like it's got a greater value. So using oversized images. And then outliers, you need to know if they're included or not included in the data when they're talking about them. Percentages not adding up to 100. Everything has to add to 100. If it doesn't, they're leaving it out for a reason. So it always has to add up. Intervals not given or uneven, you want to look for missing chunks. Of data. So those are the things that you want to make sure that you pay attention to with that. So I'm going to end this video now, and I'll do another one that shows you just how to go into that, and I'll just give you better examples looking at the graphs.